forget yesterday afternoon, so I posted it there this morning. If you guys were looking for it, it should be there now. All right, friends, shall we get started? What? No, but I got my guidance for socks. Yeah, you put the TikTok guidance for socks, and all I saw was a black sock. And I was like that. It was so quick. I'm sorry. It was. That was the end of it. I don't know what you expected. For you to like check out my messages. Manera, Ava just does not have a future in
Yeah,
there is
expecting like the entire fall.
like like an unboxing video. Those are pretty entertaining. Right. All right, guys. Make sure you submitted your work from yesterday. Anybody have any questions on that stuff from yesterday? Everybody's okay on that? That's like pretty straightforward, right? Like pretty straightforward. All right, you're gonna need your periodic table today. I'll kind of give you a heads up. Today we're gonna do a lot of the same stuff we did yesterday. We're gonna take down some definitions today. Yesterday we didn't really define anything right, so we want to have some definitions written down. And then we'll actually start talking about ions today as well, which I alluded to yesterday. Remember yesterday, all we talked about were atoms, okay? All right, so open up today's assignment. It should look something like this. There's a lot of vocab for us to kind of just define, have some good definitions here, but hopefully this won't take us too long. All right, I'm gonna go ahead and type in, I think, our definitions here, guys, to kind of save some space. All right, so let's start with electrons. To define first for you, electrons, protons, and neutrons, we call those the subatomic particles. All right, I had to squeeze that in there. Subatomic particles. All that means is that they are inside of the atom, okay? So they are within the atom, okay? All right, so electron, these are going to be very simple definitions for us, okay? Let me just go ahead and make that font a little. So electrons are negatively charged particles. Let's call it a subatomic particle, just to be even more specific. And I'm also going to kind of like write down also that it is the smallest particle that we have. All right, like I said, very simple definitions here. So for proton, we'll define that as a positively charged particle, subatomic particle. And I'm going to say that it is in the nucleus, bless you. All right, for a neutron, you guys know this is the neutral subatomic particle, and this one is also in the nucleus. All right, so that's really just a review of those things that we talked about yesterday. We also talked about atoms yesterday. We're going to define this as the basic unit of an element, and then I'm also going to put in here neutral charge. Okay, that's really important that we keep, it's really important that we keep saying that to ourselves, because we're gonna start ions today, all right? And then once we get into ions, like they're gonna kind of be our focus, and you just have to keep it in the back of your mind that atoms are going to be neutral. Okay. Now, when an atom is neutral, or because an atom is neutral, what does that mean about the number of protons and the number of electrons? What does that mean about the number of protons and the number of electrons for all atoms? They're equal. They have to be the same. So number of protons has to equal number of electrons. That looks low. Okay? That's what you want to keep in the back of your mind when you think about atoms. All right, ions. You guys we've learned about ions before. We'll call this an atom slash molecule. Oops. Molecule with a net electric charge due to the loss or gain of electrons. All right, any questions or concerns on anything right now? Everybody's okay? I'll give you a second here. It looks like people are still jotting stuff down. All right, so what I have for us next here is literally I have just chopped the oxygen block from your periodic table and put it onto this note sheet. So we kind of want to label everything that we have here. The good thing is you guys actually know basically everything that we have to label on this diagram. So the top number is our atomic number. The O is what we call the symbol. Oxygen is the name. And then the 15.9999, which there should be a 4 at the end of that, is something that we call the average atomic, bless you, mass. We have known that prior to this as the molar mass. Right? Those two terms can be used interchangeably, all right? I'm probably going to start calling it the average atomic mass just because we're going to learn a little bit more about that next week. But notice that this is not the same as the mass number, okay? So maybe even we want to include like a little star here and say mass number is not the same as the average atomic mass. Okay, just as another warning or reminder for you. Okay? All right, so 4 more vocabulary terms. Okay? The next one is atomic number. So atomic number is the number of protons in the atom. And then I also want to add to that, let's say this identifies the element. All right, yesterday we had a question, and we think it was towards the end of the worksheet, and it was like, which one of these things would change the identity of the element, right? And I hope that you all picked, I think it was letter C. It was the one where they had to like add some protons or take away some electrons, right? Because as soon as we mess with the number of protons, we mess with the atomic number, which means we mess with the element, okay? You want to keep that kind of train of thought in the back of your mind. All right, isotope. Now, we briefly mentioned this yesterday. We're still not really going to talk too much about isotopes until tomorrow, but let's go ahead and define them just so we have our definitions in one space for you guys. So one of 2 or more atoms that have the same atomic number, but a different number of neutrons. And I'm going to put in parentheses there. So different mass numbers. All right, we saw those yesterday. I think we had isotopes of lithium, and we also had isotopes of carbon on like the second page of our worksheet yesterday. All right, mass number, we're going to define that just the way we defined this yesterday. Actually, the number of protons plus the number of neutrons. Pretty straightforward there. All right, and then I want to go ahead and define average atomic mass, even though we won't learn more about this until next week, but we will have our definition here. Put the definition down here. All right, so we'll define this as the sum of the masses of isotopes, each multiplied by its natural abundance. All right, again, don't worry too much about like that definition today. We'll go ahead and learn more about that next week. Bless you. All right, everybody okay so far? All right, so let's look at what we have down here. This is called a complete atomic ionic symbol and its name. All right, very fancy stuff here. It's really not that deep. Let's go ahead and circle some of the things on the potassium ion, and we can figure out what the heck they are, okay? This 39 at the top here, that is the mass number. Oops. Okay, and the 19 at the base is the atomic number. All right, the K is obviously the symbol. And if we're writing this for an ion that has a charge, your charge will be in the upper right-hand corner. If it has one. All right, so basically what I can tell from this potassium symbol is the mass number, okay? And then I would be able to figure out the number of protons, the number of electrons, and the number of neutrons. All right, so can anybody tell me, based off of the information we have so far, how many protons this potassium has? Eva? 19. And how many electrons does it have? 19. All right. And then how many neutrons does it have? What are we going to have to do to figure out the number of neutrons? We're going to have to do some subtraction. 39 minus 19, which gives us 20, right? The other thing that we can now say that we haven't really been able to, or we haven't really necessarily had to say up until now, is that this is an atom. And I know that because it's neutral, right? If you're looking at the magnesium next to it, you can clearly see that there is a charge up here. We don't have a charge on the potassium, which means that it's an atom, which means that it's neutral, so the protons equal the electrons. Okay? Does everybody feel comfortable with that? All right, let's take a look at magnesium. Here's where your mind's about to get blown, okay? How do we deal with charges? Charges can be a little tricky at first, so if you don't catch on automatically today, please don't feel frustrated with yourself. All right. Here's the deal. The only way that I can have a charge, whether it's a positive charge or a negative charge, is if I gain or lose electrons. Okay? Here's the kicker though. Electrons are negatively charged. So if I gain electrons, that ion will have a negative charge. Okay? It sounds a little backwards, right? Usually when we gain something, we become more positive, right? If we add in mathematics, we get more positive, we get a higher number, bigger number. But because we're gaining negatively charged particles, that's why we form a negative charge on the ion. All right? So if I lose electrons, you can probably figure out the opposite here. The ion will have a positive charge. Okay. Now, in terms, bless you, in terms of all of this, I'm going to write another kind of star thing. Everything is based off the number of protons. And I'm going to explain what I mean by all of this in just a moment. Okay? I'll give you a second to jot that stuff down, and then we'll go ahead and talk about how we figure things out for this ion here. All right, so just like we started with potassium, I want us to figure out the number of protons, the number of electrons, and the number of neutrons. Now, protons are always to be done first, okay? The reason behind that is because those protons really equal the atomic number, which is the identity of the element, okay? So based on this symbol here, the number of protons is 12, because we know that that 12 down in the bottom left-hand corner is the atomic number. We know that the atomic number is equal to the number of protons. All right, so here's where I want to challenge you a little bit. If I tell you that I have 12 positive particles in this ion, and the overall charge is positive 2, how many negatively charged electrons would I have in this ion? Anybody want to take a stab? I heard it. Casey? 10. Does everybody understand that? All right. So you can't mess with the number of protons, right? You might have been like, oh, I'll just add 2 more protons and I'll have 14 protons because then I'll give me a positive 2. You can't do that because once you do that, now you're dealing with silicon. You're not dealing with magnesium. Okay. You don't want to mess with the number of protons. What we can mess with is the number of electrons, okay? Because I have a positive 2 charge, that means I am going to lose electrons. And the way that we figure this out is the number of protons minus the charge gives us the number of electrons. Okay? I know it sounds backwards. When you have a positive charge, you're going to subtract that from the number of protons, and that's going to give you the number of electrons. Okay? I think that at our level, we are intelligent enough to kind of reason out, all right, it has to have 10 electrons because my overall charge is a positive 2. All right? Everybody follow that? We'll do a bunch more examples today, okay, so don't worry. What about my number of neutrons? How am I going to figure that out? John? 24 minus 12, so that leaves me with 12. All right, so guys, the only thing that's affected by the charge is the number of electrons, okay? And that comes from the fact that the only way we get a charge, whether it be positive or negative, is by either gaining or losing electrons. Okay? Any questions on that at all? All right, let's do this chlorine over here then. So we want the number of protons, we want the number of electrons, and then we want the number of neutrons. All right, what is my, how many protons do I have here?
So
17. All right. Now my charge is -1, so let's think about it again. All right. I've got 17 protons, so that's 17 positive. Overall, I want a -1 charge. So how many electrons do I need to have that -1 charge? Not quite, because if I had 16, I would have a +1 charge. Eva? 18. All right. So for my negative charges, I'm going to take my protons and add the charge to it to get the number of electrons. All right. You have to keep in mind in the back of your head, electrons are negatively charged. So when I gain them, my ion has a negative charge. It's backwards. I know it seems backwards. Okay. All right. What about number of neutrons here? What do I have to do to get that? 37 minus 17, that gives us 20, I think. All right, how do we feel? Questions or concerns? Everybody's okay so far? All right, cool beans. Are you ready to draw another atom?
No.
No? Maybe. All right, it's not that bad. All right, so it gives us like step-by-step direction, so this is pretty nice. The first thing it tells us to do is draw 5 protons in the nucleus of the atom. Okay, so protons, we're going to draw those with a positive, like plus sign in the center. And so we want 5 of them, so go ahead and do those first. All right, the next thing it says is draw 6 neutrons in the nucleus. So we'll just leave those as blank circles because they're neutral. All right, it says draw 2 electrons in the first energy level and label them with their charge. All right, so that first energy level, I guess we'll make it this one out here. So they say 2 electrons. We followed that philosophy yesterday, right? We put only 2 electrons on the first ring. And then it says draw 3 electrons in the second energy level and label them with their charge. So we'll go out to this second ring here. All right, that wasn't too bad at all, right, guys? The question 5 asks us what element is represented by this diagram. John?
Boron.
It is boron. How'd you figure that out? Good. On the periodic table, number 5 is boron. John knows that the number of protons is equal to the atomic number, so we find number 5 on the periodic table is boron. All right, what would be the complete symbol of the element? The complete symbol is like this that's listed down here, okay? Like these guys down here. All right, like we just looked at the bottom of the first page. So the complete symbol, you're going to have boron symbol, so that's B, right? At the top left, you're going to have the mass number. The mass number is the protons, which is 5, plus the neutrons, which is 6. That gives us a mass number of 11. In the bottom left-hand side, we have the atomic number or the number of protons, so we'll have a 5 here. Do we have a charge, or do we have an atom? Ava, what do you think? A +3 charge, she says, okay? How many protons and how many electrons do we have? John? Okay. Not quite. Jalen, what do you think? Okay, so we have 5 protons and 5 electrons. Ava, thank you for saying a positive 3 charge, because does anybody know what Ava's looking at right now? I say that? She's looking at the top of the periodic table. Now here's what we need to understand. Every element on the periodic table can be one of 2 things. It can be an atom, like this right here. This is an atom because the protons and the electrons are equal. But every element on the periodic table can also be an ion. When it is an ion, it will have that positive 3 charge. If this were an ion, a boron, it would have that positive 3 charge that we see on the periodic table. Okay? So just because the charges are listed there doesn't necessarily mean we're dealing with an ion. We can still be dealing with an atom. Okay? And that's why we have to be so careful, okay, when we have questions like this chart that we're about to fill out. We have to be so careful to be dependent on figuring out the number of protons and the number of electrons and determining the charge based off of that, okay? And you're going to see what I mean here in just a moment. All right? Anybody have a question or concern on the drawing of the atom here? Correct. Since the protons and the electrons are equal, this is an atom, so it would have no charge. What? What if they weren't equal? So if they weren't equal, then it would have a charge, right? So if it were, let's just say, you don't have to do this on your paper, but let's just say I got rid of those 3 electrons. So then my number of electrons would be 2, my number of protons would be 5, so I would have a positive 3 charge because I'd have 3 more protons than electrons. Okay? Good question. All right, let's jump down here to this table. Now, I will be honest with you, on your Unit 10 test, which not anytime soon, all right, but you will have a gigantic table just like this one, okay? By that point in time, this is going to be really simple for you. Right now, it might seem a little scary, but we're going to work through this one together, okay? All right, so let's start off. We'll go ahead and do the first column for the silver. A couple of things I like to take note of right at the beginning. Is there is no charge listed here on our silver, right? If there is a charge, it's going to be up here like there's this little charge here on the phosphorus, okay? So there's no charge. So I like to come all the way down to the bottom and say for the charge neutral, or if you like instead, you can write 0, because 0 charge means neutral. And then I also like to identify this right off the bat as an atom, because if it is neutral, it has to be an atom, and vice versa. All right, so we'll go ahead and start at the top of the column now. What is the name of, for AG? Silver. All right, oops. And the atomic number is given to us here. Is it the 47 or is it the 108?
47.
Good. And the mass number is also given to us here. It's 108. All right. We know that the atomic number and the number of protons are always going to be equal to each other, regardless of whether it's an atom or an ion. Okay? So how many protons do I have? 47. All right. How am I going to figure out my number of neutrons? What am I going to subtract? Good. So 108 minus 47. Can anybody do that mental math? 61. Excellent job. All right. Now, what about the number of electrons? We've identified this as an atom. It's a neutral charge. So what does that mean about my number of protons and my number of electrons? Ava? They're going to be the same. So we're going to have 47 electrons. Okay? Everybody follow me so far?
Yeah.
Beautiful. All right, let's do the next one. So we've got, we definitely have a charge. So I like to start at the bottom and say that the charge is a -3. And this is an ion. And if I wanted to be more specific, would you call this an anion or cation? Anion, very good. We can write that in there just because. probably a good review for us to use those words. All right, so what is P the symbol for? What's its name? Phosphorus. All right, what is its atomic number? 15, good. What about mass number? 31. All right, my atomic number and my number of protons are always equal, so I have 15 there. All right, what subtraction am I going to do for my neutrons? Beautiful. That's a little easier mental math. I think I get 16 for that one. All right, number of electrons. Now be careful. We have a -3 charge, okay? So what that really tells me when I have a -3 charge is that I have to have 3 more electrons than protons, okay? You can think about it that way too. So what I would do here is take my 15 protons and add 3 to it to get 18 electrons. All right, how are we feeling with the charges and the number of electrons? We're feeling okay? All right, beautiful. All right, I'm gonna do one more with you, and then I'll let you guys do like the last two so that you can get kind of an idea as to how to solve these out on your own, okay? All right, so this is all blind for us. Let's see if we can't figure something out. I know that my atomic number is equal to my number of protons, so I'm pretty sure I can fill in that number of protons as 17 here, which can help me figure out what element I'm dealing with, right? If I find number 17 on the periodic table, what element am I? Fluorine. So I can go ahead and fill in the name and the symbol. And I can fill in the bottom left-hand corner because I know the atomic number is 17. All right, for my mass number, what two numbers do you want me to add together here? 17 and what? 19. And that gives me 36. All right, so my mass number goes at the top of my symbol, bottom or top left, I should say, for my mass number. All right, they tell us that the charge is 0, which means it's neutral. So am I an atom or an ion? Atom. And then my electrons, what do I do there? Same as protons because I am an atom. Beautiful. So 17 as my number of electrons. All right, and notice that we don't have a charge up on that Cl, okay? We just leave it blank because there's no charge because it's an atom. All right, questions or concerns, guys? I'm going to go ahead and try the next two columns. All right, I'll give you about, I don't know, minute to 2 minutes, and then we'll go ahead and see if we figure those out correctly. Okay, take your time. Don't just rush through it. Kind of think, really try to think through what you're doing. How are we doing? Do we need more time or are we okay? Ready to check them out? All right, is anybody brave enough? It's okay if you got everything wrong. Is anyone brave enough to share with me what they got straight down the column for the next one that we have here? Nobody's brave enough? All right, that's fair. It's a little scary. Jalen? Go, Jalen. Okay, go ahead.
I feel like how
Yeah, of course.
the name about
Yes, lutetium. Good.
71.
Good.
That's 71 again.
Beautiful.
You're
Good.
I don't think so.
Fantastic. That's okay. With the information you got, we can easily fill that in. Oh, yeah, round of applause. How about that? Very nice. Love that. All right, and then I think we can do just that is the symbol up there. All right. How many of us got those answers? Anybody need to have an explanation here for anything? Virtual friends, you're okay? All right, good. So, yeah, weird element. We haven't really heard that one before. So good job finding that one on the periodic table. Okay, here's the really challenging one, the last column. Does anybody have the courage to do this one for me? Tyler? Okay, go for it.
Oh, I got Gizmo.
Okay,
83,
okay,
209,
okay.
3 with the mom.
+3, and it's an ion, he says. How many of us agree with Tyler's filling in here? Yes, yes, yes. Okay, so let's talk about how he got that +3. Oh, John, go ahead.
Would it be -3?
Aha, let's talk about that. So we've got 83 protons and 80 electrons. So what that tells me is that I have 83 positive particles and 80 negative particles. Because I have more of the protons, that's why I have a +3 charge. And I have 3 more protons than electrons, and that's why I have a +3 charge. Justin? Yes, that would be a cation if we want to be more specific. Excellent. All right, and then let's go ahead and fill in the symbol at the top. So we've got 209, 83, Bi, and then we put the charge in the upper right-hand corner there, so positive. All right, guys, how do we feel? Feel okay? We're going to spend a lot more time like dealing with the cations and anions and the -3s and the positive charges and stuff like that, okay? All right, so here's what I would like you to do. You have kind of like fill in the blank questions here. They're a little, I didn't write them, so they're a little crazy, but they're pretty like easy to do, I think. The only one that I'm not sure you might, I think you might get tripped up on is number 8. So let's slide down there. It says, give the isotope symbol and number of neutrons in one atom of the following elements. So the first thing that I want to make note of is that these are all atoms, which means they're all going to be neutral. Okay, and by isotope symbol, what we're talking about is basically what we just learned. So Ba, and then that number that they give you here, like after it, that's the mass number. So it would be Ba, and it would be 138. And then I need to look at barium on the periodic table. Its atomic number is 56. And then they want you to tell the number of neutrons. So I would have to do 138 minus 56. 2, 13. Oh my God, my brain's hurting. 82? That sound about right? Kind of, sort of. All right, let me not thrash out the number 1 there for my subtraction. All right, so that's what you want to do. That's what that isotope symbol means. Okay, pretty straightforward. Everything else should be pretty okay. And if you're like tripped up on some of the wording, don't like stress out about it because some of the wording is just a little tricky with like fill in the blank stuff. Okay? But this is what I want you to do for your assignment for the rest of class today. You'll go ahead and submit this for your assignment due before class tomorrow. Okay? Anybody have any questions or concerns before I let my virtual friends go? Everybody's okay? All right, virtual peeps, have a wonderful rest of your day. If you have a question or concern, you can reach me on Canvas or hop into the Google Meet after class, okay? Have a wonderful Thursday.
Thank you.
You're welcome.
Thank you.
See you guys tomorrow.